Hi, boys and girls. It's Mr. Wasserman again, continuing our evaluation of our school year in everyday math for fourth grade. We are in study guide. Now we're looking at problems 2, 3, and 4 and all their parts. Number 2 tells us that the rule for the pattern below is multiply each counting number by 8. Or in other words, we are looking for multiples of 8. So if you were to skip count by 8, starting at 8, you would go 8, 16, 24, 32, 40, and so on. Okay? And where they stopped was right here with 15 groups of 8. So if you add 8 to itself 15 times, you will get 120. Now then, starting with 16 times 8, write the next 5 numbers in the pattern. So what we're looking for is 16 times 8, 17 times 8, 18 times 8, 19 times 8, and yes, 20 times 8. And the way you would accomplish that is one of two ways. You could either take each multiple and multiply it, 16 times 8, or you can start with where you left off with 120 and then add another 8. That would give you your next multiple of 8 after 15 groups of 8. Adding another 8 to 15 groups would give you 16 groups, and so on. Describe the pattern that you see. Now, we know that you're skip counting by 8s, so don't tell me that, oh, we're increasing by 8s. That's not what we're looking for you to see. What we want you to do is look at the actual digits involved in the multiples of 8. Do you see an emerging pattern? Do you see anything repeating over and over? That's what patterns are. It's a sequence of repeating images, words, phrases, numbers. I'll let you take a look. Okay, number 3. Mason wrote down a 6-digit whole number. When he rounded it to the hundreds place, the answer was 1,000,000. Circle the numbers below that might have been Mason's number. So again, we're going to want to use the roller coaster model, where we have a hill at the top, and on one end of the hill we have one place value, and on the other end of the hill we have the next largest place value. So if we're rounding to the hundreds, what we need to do is we need to look for what number, first of all, is in the hundreds. And you'll notice that each and every one of these numbers has a 9 in the hundreds place value. But what we really need to determine is what is the place value of the number next to it. That's the tens. Because when we round to the nearest 100, we have to look at the previous place value, which is to the right of that place value. So if I'm rounding to the nearest 100, I'm starting with 900 on one side and then 10 hundreds, otherwise known as 1,000, on the other side of that hill. And the midway point would be 950. So, when I'm rounding to the nearest 100, I have to ask myself, is my number as big or bigger than 950, the halfway point? Because if it's bigger, then that little roller coaster cart is on this side of the hill, the right side, and gravity would pull it down the slope towards the new place value. But if it hadn't made its way up the hill enough, if it's less than 950, as far as it went up, it would go rolling back to where it started, or round down. And that's how we round. So they're asking you to figure out which one of these numbers would round to the nearest 1,000 or 100, okay? And then what would that make the rest of the digits do when you're rounding to the nearest 100? Would that push that number to 1,000,000? Okay? And then question B is there a number above here that has these digits and these place values. So you'd have to inspect all of the numbers, these 4 6-digit numbers above it. Look at the way that these digits would line up. Are any of these numbers represented by these place values? You're then asked to compare two numbers from 3A with greater than, less than, or equal signs. So you're going to create either an equality or an inequality. Okay? So you could do, say, 949,999 compared to 998,999. What symbol would go in between, greater than, less than, or equal to? And then looking at place values, the digit 8 in 998,999, what is the value of that 8 compared to this 8 in 999,998? How much bigger? How many times? Okay. And then finally on problem 4A and B, you're adding and subtracting. And as you can see, these are large number addition and subtraction problems. So it would be useful for you to reconfigure the problem so it's lined up vertically instead of the way that they present it to you, which is horizontally, because there's going to be some regrouping involved. Okay, so for example, 89,532, when you write it directly below 73,864, you can start to see where you might have to regroup some place values. Here's the other problem. 42,000 minus 16,294. Now, I'm going to show you how a lot of kids would approach this problem and why that approach is wrong. So when I'm subtracting a number from 0, my mind should say, wait, 0 means nothing. I have nothing to subtract from, so I can't do that. But a lot of times kids' brains will want to flip these two numbers because that's logically the easier way of thinking about it. So instead of subtracting 0 minus 4, kids will do 4 minus 0. And of course, when you subtract 4 minus 0, you get 4. 9 minus 0 is 9. 2 minus 0 is 2. And then they might subtract 6 minus 2 is 4. And then they would flip it without even thinking about it back in their heads and subtract 4 minus 1. And they would get an answer that looks like this, 34,294. Now, some of you might be thinking, well, what's wrong with that problem? If I were to take 34,294 and add it back to 16,294, theoretically, I should get this number, 42,000, because subtraction problems are the reverse of an addition problem. So theoretically, if I add these two add-ins together, I should get this sum, 42,000. But as you can see, when I start adding, it becomes a completely different amount. 50,588. It does not work. That's because you cannot take a whole number from 0. You would have to borrow. And where are you going to start borrowing? Well, it would be right here in the 10,000s place value, because all the other place values do not have enough to subtract the amount down here. Okay? So you're going to have to do some borrowing. Okay? Well, that's how you would go about tackling problems 2, 3, and 4. We're going to continue with the video tutorials for future problems. Until we meet again, keep on going.